Histograms. What a histogram really is, it is nothing more than a connected bar graph. And so, we're going to do some examples of histograms and talk about what some information that they represent. Now there's a possibility that the bars will not be connected because there could be gaps in the data. Hopefully we'll see an example like that. The horizontal scale represents data values, or classes I should say, classes, and the vertical scale represents the frequencies, the number that's in each class. And so you can look at this and see there's some important information here, but you can talk about it pretty easily once you see a histogram. The center, you're going to approximate where the middle of the histogram is. The shape is a big deal. We're going to talk about that here in just a few seconds. Tell you how far spread out the data values are. There's a lot of bars. The data values are spread out. Outliers, you may have all kinds of bars and then have nothing and then have like another one. That's like an outlier. So an example, well, relative frequency histogram is the same thing except as a regular histogram, except it uses the relative frequencies, which is the F divided by N. Information from other videos you may have seen that I've had. So an example is like this. Here you have your classes, and here you have your frequencies. And so on the frequencies are almost always on the vertical axis, vertical line, the y-axis if you think algebra. And then the classes are almost always, actually they are always on the horizontal axis. So when you look at this, I'm trying to get them on the same page. I may have to minimize this just a little bit. So when you look at this, you notice that we don't use these actual classes, and I'll show you why. If you have something like this, and then if you ever see me do that, or see me do that, that means that this x-axis has been crunched together, because I want to start at like, if I do start like 75 and then go up to 124, and if I label the next one as 125, and I start to draw my bars, there's a gap. That's not good. So there's two things we can do. Either we use boundaries like this one does, class boundaries, or we'll use midpoints. We'll do an example of each here in just a few minutes. Now to get to the boundaries, what you want to do is you want to take 124 plus 125 and divide that by 2, and what you're going to end up getting is 124.5. So that's where that comes from. Now once you have that one, if you take, that's a boundary. Now if you have the width, which we do have, because the width is just taking this lower limit minus that lower limit, we get 50. So to get this boundary, what you would do is you would take 124.5 minus 50. If you want to take out the calculator, that is fine by me. Nothing says you can't. 124.5 minus 50, and you'll get the 74.5. That's right there. And then if you keep on adding 50, you'll see the other ones. We already know the 124.5 is correct. And then you add 50 again. 174.5. Add 50 again. 224.5. And add 50 again. 274.5, and add one more 50. And you need the last one because we need to have an upper limit up here. So once you have those, all you're going to do, you label them. You're supposed to mark them off. They're supposed to be evenly, or even from there to there, there to there. The distance is, and they are, because the class width is 50. Then you label these. You can label by ones, you can label by fives, however you need to. Based on these data values, the highest one is 24, so 5 makes sense. So the first one goes up to 11, so you see there's like 11 there. The next one's 24. If you want to write it up there, you can. And then 10 will be right on that mark. And then 3, and then 2. And so we'll do some examples. But that's just the example already done. But we're going to actually do examples right now involving histograms. Before we do that, I said right now, I did not tell the truth. We're going to talk about the shapes. And these are very, very important. This one right here is called the bell-shaped curve. I'm going to blow that one up a little bit. Bell-shaped normal curve. That is humongous. I cannot stress that enough. It looks like a bell. Humongous. If you take a good look at it, it looks like it's, if you could draw the middle right there, it looks like it's the same over there as it is over there, so it's symmetrical. And it's the shape of a bell. This is uniform. Uniform means it like follows a line on top. It's the same. Almost. It's not exactly, but it's pretty close. Skew to the right means it tails to the right. And this one, skew to the left, means it tails to the left. Tails to the left. Look at the handwriting. And so, what I just said probably is already summarized here. Bell-shaped, uniform. That should be darkened. Let's go ahead and darken it. You want to? Yep, I didn't really have to do that, but I did anyway. And so, uniform follows the line. Skewness as scale to the right, it tails to the right, and the skew to the left, it tails to the left. I like to use my words; they're easier to understand. Here comes the skewness. So now let's do some examples. So the question is, you got a histogram. How many households? How many households total? So what you want to do is to find the total households. You want to add the top of the bars. So that's like a 20, and that's like a 50. I'm just approximating. I'm looking over there. So that would be 15. That looks like it's a 10. And that looks like it would be 5. I don't use those numbers, because that just tells you the number of TV sets. We don't want the number of TV sets, we want the number of households. How many households? And so the frequency here, it says number of television sets per household. So this would represent the households. The number of TV sets would be quite a bit different. So it's find the total number of households. You just add those numbers on top of the bars. 20 plus 50 plus 15 plus 10 plus 5. And that grand total is what? 70, 85, 95, 100 are in this sample. Got that? In this example, there's that line that disappeared. This one involves the relative frequencies. It just shows you that it's using percentages over here. That's okay. Let me make this a little bit smaller so we can see it all on one screen. The blood pressure's what class width was used to construct the relative frequency distribution. And keep in mind, the classes are down here. And so to find the width, the class width, you would just take and subtract any of these. 110 minus 100. It's 10. It'd be the same thing throughout. 10, 10, 10, doesn't matter. And that's it. Not that big a deal. Class width of this one uses midpoints. So the classes are down here, once again. So the class width or width. You can use midpoints to do the exact same thing. You can take 2 minus 1, you get 1. 3 minus 2, 4 minus 3, 5 minus 4, doesn't matter. Still get a 1. For this problem, we want to construct a histogram 5 classes, lower class limit of 19.5, and a class width of 10. So let's think about this for a second. Classes, we want 5 of them. So 19.5 would be the first one, or the lower limit of the first one. Class width of 10 means we will add 10 to get the lower limit of the next class, and then so on, so on, and so on. Now, since these are lower or boundaries, because that's what these actually are, what we're going to use is we're going to use 29.5 as also the upper limit here, because for histogram you're going to see why we want to do that. Well, the reason is because I want to start that with a 19.5, and then that one's going to be a 29.5, and then 39.5, 49.5, 59.5, and 69.5. So this 29.5 is being shared with 2 different bars, so that's why I have that there. It's being shared. And then you want to do the frequencies. I'm just doing it over here. It's like a frequency table, because it really is. These are the classes. And what I'm going to do is I'm going to do a different way than maybe in the previous video. I'm looking for all the numbers from 20 to 29. See that? None of these have decimals. So 20 to 29 is what I'm looking for. So 1, 2, I see 2. And then 30 to 39. 1, 2, 3. Now if I miss a number, it's no big deal, because I'm marking them off as I go, so I can always go back and fix it. 40 to 49. 1, 2, 3, 4, 5, 6. And then 50s. 1, 2, 3, 4, 5, 6. And then 60s. 1, 2, 3, 4, 5, 6, 7, 8. And before you send me an email saying there's a mistake, of course there's a mistake. I told you how you can catch yourself. See that 32? I didn't count it, or did I? Let's see. 30s. 1. Maybe I just didn't mark it off. So the number I'm looking at is 32. Did I not count it? Let's see. 30s. 1, 2, 3. So no. So that means there's actually 4 in there. But see how you can get yourself by using this table? There's 26 voters, and I always do this. This is another way to catch myself. I want to add these up. 2 and 4 is 6, 6, 6 and 12. 12 and 6 is 18, 18 and 8 is 26. You know, just do it this way. 8 and 6 is 14, 14 and 6 is 20, 24, 25, 26. So what I have now, I have my classes already labeled for me. Then my frequencies will be over here. And the highest number is an 8. And 1, 2, 3, 4, 5, 6, 7. I can probably go ahead and extend that. And put another one there and just count by ones. You could count by twos. But 8s at ones are actually better. So now here we go. This is really difficult to do. So the first class, 19.5, 29.5 is 2. Make sure you go up to 2. Now I want to make sure that when I draw my next one, 29.5, 39.5, I go up to 4, but I gotta make sure they're connected. So what you do is you just extend here, go up to 4 as good as you can, and then come back down. And the next one is 6. Trying to get as close as you can to even. Next one is 6 also. I just extend it over. And the last one is 8. So let's go up where we think is 8 and then come back down. And there you go. Cool. Now that looks like it's skewed left a little bit. See why I might say that? The tail's a little bit to the left. There could be a debate on that, but it looks like it does a little bit. And what is the approximate age at the center? Now if you look at the center, there's more values over here. And there's fewer over there, so it's going to be tilted over here somewhere in here. So I'd say that the answer to the center is around 50. Makes sense? Yeah, makes sense. Then let's do one more. This one already has everything given to us, but this time we're still asked to draw a histogram, but this time we want to use the class midpoints. So to find the midpoints, or the midpoint of the first class, you take 0 plus 2 and divide that by 2, because that's an average, and you get 1. So my midpoints, so for the first class, I need some space up here. So I have a 1. Now if you take a look at this, the width is going to be 3 minus 0, which is 3. So if I have the width of 3, my first midpoint is 1, that means I'm just going to add 3 to get the next one. And then 3, and then 3, and then 3, and then 3. And if you take a good look at it, it's the one in the middle. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to use those and my frequencies to draw the histogram. And then we're going to ask ourselves, is this normal? Is it normal distribution? So once again, I'm going to minimize this just a little bit, or shrink it a little bit, so you can see everything on one page, or one screen I should say. So when I label these, I'm using the midpoints. Just go, how do we want to do this? I'm going to call that one 1, and then I'm going to call that one 4. Is that what I want to do? Yeah, and then 7, and then 10, and then 13, and then 16. And up here my frequencies are 10. 1, 2, 3, I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I use the ones because the highest one is a 10. So what I'm going to do is, so from 0 to 2, I'm going to go up to 10, and so that means I'm going to do this, and go over like this. And then 3 to 5 is 1, so my midpoint is a 4, see that? And the next one is 7. And also has a midpoint 7. Midpoint 10 is also 7. Midpoint 13 is a 1. And then midpoint of 16 is 4. I'm just trying to get as close as I can, trying to be as accurate as I can. What do you think about that? Is that normal? No, it's not bell-shaped at all. It's not symmetrical. So, no. Not normal. And that's it.